Hi, welcome. So welcome to today's discussion. Basically, today's discussion was centered on normal curve distribution. So in our previous video, I gave you some brief introduction about some features when it comes to the normal curve distribution. One thing about the normal curve distribution is that it is something which is bell in shape. When it says it is bell in shape, you could see that it has more or less like a hunchback. It forms, its structure is more or less like a bell shape. So let me try and annotate it so that you get it well. This is the bell shape that I'm talking about. Like a form of a bell. So we normally say it has a bell shape. Apart from that, it is symmetrical. So when you say something is symmetrical, then it means that you can divide it into two equal halves. So it means if we assume that the normal curve distribution has a total area of 100%, then half of this area, this half, is 50%, and the other half here is also 50%. That's what basically it's all about. So that's what I mean by it is symmetrical. Again, we normally say that we transform the scores into a standard score, meaning that we use the z-scores. So when drawing the z-scores will fall under the x-axis. And currently, you know how to calculate z-scores per the previous video that I did. So in case you are having issues with how to calculate z-scores, then kindly watch the previous video, and it will give you detailed information about what z-score is all about. All right. So we also say that with the normal curve distribution, the mean is always 0. So the mean is the center, which is 0. So this is the mean. And also, apart from the mean, the median and the mode is also 0 when it comes to the normal curve distribution. So they all fall under this side, the 0. And the normal curve distribution has a standard deviation unit of 1. So if you see, this is the mean. Then there's a unit of 1. Then there's another unit of 1. Another unit of 1. So that's how the normal curve distribution is like. It has 1 unit, 1 unit, 1 unit in that regard. Also, we say that the z-values, the z-scores, their values, which can be found at the left-hand side, are negative. So that's why when you check the negative side, the values there are negative. Because if this is the mean, then it means that whatever values on our left-hand side, they are negative. And as they begin to be farther away from the mean, so for instance, -1 is kind of farther away from the mean of 0, telling you that this value, -2, is what? It's very, very low as compared to -1. So it means as they begin to be farther away from the mean, they have smaller values. But the reverse, that's when the values or the z-scores values, they are around the left-hand side of the mean and they are farther away from the mean, they become larger because when you compare 3 and 0, 3 is larger than 0, which is the mean. 0 is the mean. So it means as the value on our right-hand side becomes farther away from the mean of 0, that value, which is farther, becomes larger. All right. And as I indicated, in situations whereby we take the z-score or the normal curve distribution, the total area to be 100%, then we can assume that if the scores fall around -1 to +1, then it means the area here takes about 68% of the total area. 68% of the total area. So if our scores are within a standard score of -1 to +1, then it means the total area covered within the normal curve distribution is about 68%. All right. But in situations whereby our values for the z-score fall around maybe -1.96 to +1.96, -1.96 to +1.96 might fall around this side, then it means the entire area covered here will be about 95% on the normal curve distribution. Okay. But in an instance whereby the z-scores value take about -2.58 to +2.58 of the total area within the normal curve distribution, then it means the values covers about 99% of the total area. So these are some of the key things you need to know when it comes to the normal curve distribution. So the next one has to do with hypothesis testing. When it comes to this course, you are tasked to know hypothesis, and hypothesis is related to the normal hypothesis that you've come across. So one might ask, what is a hypothesis? So we normally say that a hypothesis is any tentative statement or a scientific guess. So it means it helps us to understand certain prediction that has been made, because hypothesis has to do with certain predictions. And when it comes to hypothesis, we have two main forms: the null hypothesis and the alternative hypothesis. The null hypothesis is normally represented with this symbol HO. We normally represent the null hypothesis as HO, then the alternative hypothesis as H1. And the alternative hypothesis is sometimes referred to as the researcher's hypothesis. The alternative hypothesis is sometimes referred to as the researcher's hypothesis. So it means that within a question, whatever prediction that has been stated in the question, that is the researcher's hypothesis or the alternative hypothesis. So in sampling our people, so let's say we want to conduct a study among University of Ghana students, okay, and we sampled maybe 20 students to represent University of Ghana, and we tested maybe their performance in statistics. So we want to find out University of Ghana students, their performance in statistics. Then as a researcher, I sampled about 100 students, gave them statistics test to do. Then afterwards, I graded and found out that majority of the students I sampled, that's the majority of the 100 students I drew from the population, they performed well. So I then assumed that the entire University of Ghana students are good when it comes to statistics. That's what inferential is all about. But before I go to the field to test this, I should make a prediction. So before I give them the test and everything, as a researcher, I should formulate my own prediction, my own hypothesis. So the hypothesis that I'm formulating is what is referred to as the alternative hypothesis. So maybe within my sample, I'm comparing males and females in terms of their performance. Then I make a prediction that, oh, males will perform better in statistics than females. This implies that that is my alternative hypothesis, which is H1. Then my HO, based on the H1 hypothesis, I could easily formulate an HO out of it by stating males will perform this time around poorer. That will be my HO, or there will be no significant difference between males and females. So you could see that I formulated two main hypotheses for HO. Why? Because HO is more or less like you are trying to provide all sorts of statements that could counteract or make your H1 false. And here comes the case, your H1 is saying males will perform better than females in terms of statistics. So what will be all options that will make H1 false? One option has to do with the fact that males could perform poorer, or between males and females, their performance will be the same. So me stating that males and females, their performance will be the same is more or less like me using the technical aspect. That's there is no significant difference. So when I say there's no significant difference, it means they will be the same, because there will be no difference between the two groups. So they will be the same. All right. So with the alternative hypothesis, you can find out, is it directional or non-directional? That's another type of hypothesis based on your alternative hypothesis. So a directional hypothesis in this regard has to do with the fact that they're telling you that the two groups that they are comparing, one will be greater than or less than. So you could see I was comparing statistics or performance in statistics. And here comes the case. I've made my own prediction and indicated that one group will be greater than the other. So I indicated males will perform better than females. So that's a typical directional or one-tailed hypothesis. So it means with one-tailed hypothesis, for you to know it, it is based on your alternative hypothesis, the kind of statement that you've made for your alternative hypothesis. So if you've indicated that males will perform poorer, you've taken a stand that one will be better or poorer. So you've taken a stand that, oh, males will be poorer or will perform poorer than females. So that's the stance that we've taken. And in that regard, we call it a directional or one-tailed hypothesis. Another way this statement could be formulated in the question by the researcher will be that, oh, in terms of performance in statistics, there will be a difference between males and females. That is also a hypothesis. That's the alternative hypothesis. So you can see that with this type of hypothesis, the researcher haven't really told us among the two groups, which one will perform better or worse than the other. They just indicated, oh, among the two groups, there will be a significant difference or influence in terms of performance. So they haven't specifically told us which one will be better or worse. So in that regard, we call this type of hypothesis two-tailed hypothesis or non-directional hypothesis. And in the course of us sampling our participants or taking a sample from a population, we are bound to commit certain errors. Definitely we will commit one or two errors. But researchers have devised ways and means of making sure that the errors are within a certain boundary. Any error above that boundary is not acceptable. So they've set up a boundary known as level of significance. And in social sciences, where psychology is part, we normally state that the number of error, which is the level of significance, the number of error anyone should commit should be within 0.05. 0.05. So when you convert 0.05 into a percentage, it means the number of error anyone should commit should be around 5%. Should be around 5%. So that at least we can say whatever research work that we have about at least 95% confidence in the work that we've done that it is accurate. So it means we should have at least about 0.95%, 0.95 confidence in the work that has been done as accurate. And we call this confidence interval, the 95% or the 0.95 as confidence interval. Then the 5% is what is referred to as the error or the level of significance. In pure sciences, they set their level of significance very high by using 0.01 sometimes. So when they use 0.01, it means that they are telling us they want the error to be less. That's 1% error. So that at least they can have 99.99% in the work that they've done as accurate, especially if you are conducting or you are trying to produce a new drug or manufacture a new drug or even manufacture a vaccine. You need to make sure that whatever drug or vaccines that you are bringing on board is safe. So it means the error should be minimal. So that's why they set it they set the error to be very, very low. All right. So in most situations, researchers going in there to either accept or reject HO, the null hypothesis. The ultimate goal of any research is to either accept or reject the HO. So in doing that, let's say within a coin tossing, or before I come to the coin tossing, in most situations, we want the error that we are doing in research to be very, very low, right? So for it to be low, we normally say that it is dependent on the sample size. That's the number of occurrences within your data, or the number of occurrences of an event that is happening in your research work. So we normally say that when it comes to error in research, sample size matters. If you have you've sampled a lot of people within your research work, it decreases the number of error that you might commit. So for instance, you want to conduct a study among University of Ghana students. University of Ghana, we are a lot, about 60,000. And someone samples 100 students. And another person samples 1,000 students as their participants. The person who sampled 1,000 students is less likely to commit a lot of errors than someone who sampled only 100 students. So that's the rationale. It means that for errors to be low, sample size matters. When I say sample size, it means the total number of people you've selected within the population to represent your study. The same applies to coin tossing. In coin tossing, let's say you are having a coin tossing with a colleague. So I'll use myself as an example. Maybe I'm having a coin tossing with a friend known as Caleb. Then we set up a rule. Whenever we flip up the coin and it is tail, it means I'm supposed to dash Caleb 10 cedis. But when we flip and it turns out to be head, Caleb is supposed to give me 10 cedis. Then the first instance, we flip. Then it is tail. Then I'm supposed to give Caleb 10 cedis. The second instance again, tail. I gave Caleb 10 cedis. So you can see that with the first instance, nothing suspicious will come to my mind. But when we do it for about 10 to 20 times or 20 occasions, and still it is turning up to be tail, I'm dashing out 10 cedis frequently, I begin to wonder what is really happening. Oh, so two things come to my mind. Is my friend Caleb cheating, or things are due to chance? Nobody is cheating here. So these are the two things that comes to my mind. And for it to come to my mind, it means that the number of occurrences should be more, so that I could then formulate certain hypotheses and find out whether I wouldn't commit too much error and all that, or I wouldn't be wrong about my friend. So in the coin tossing, as I said, these two things comes to mind. Is it my friend playing fairly, or he's cheating? So when these two things comes to mind, also I am bound to make two decisions, whether to stop playing the game, or I assume that things are fair, so I'll continue to play the game. So that is what I have indicated, or I have tabulated. So it means that if I continue to play, it means I'm retaining HO. But the moment I stop playing, it means I am rejecting HO. So as I said, these are the decisions available or at my disposal, me continue to play or stop playing. And what would inform me to continue to play or stop playing? Based on the thinking patterns, the two thoughts that came to mind, whether my friend is cheating. So my friend cheating, it means that things are biased. So it means H1 is true. The alternative hypothesis is true. And HO is false. And a thought coming to my mind that everything is fair, things are due to chance, it means that HO is true, but H1 is false. So it's in an instance whereby I continue to play when I know for sure that things are due to chance. I continue to play the game. It means I retain HO when I know for sure that HO is true. Things are due to chance. Nobody is cheating. Then it means, what sort of decision have I made? Is it a correct decision or a bad one? Mix, continue playing when things are due to chance. Nobody's cheating. Obviously, it means that it is a correct decision. Nobody's cheating. And I continue to play. So it means I have made a good decision out of this. But in an instance whereby I stop playing, when in reality, nobody was cheating, that means HO was true, then it means that I have committed an error. But in an instance whereby I still continue to play, I still retain HO, that's continue to play, when in reality, my friend is cheating, then it means that I have committed an error. Then again, I stop playing when my friend has been cheating. Then it means that I have made a correct decision. So it means that in statistics, two main errors are bound to happen. Two main errors are bound to happen. And the first error, whereby I stop playing when in reality, things were due to chance. We call it type 1 error. So it means they can ask you, what is type 1 error? It means that type 1 error is the probability of you rejecting HO when HO is true. Or they can indicate the probability of rejecting a true null hypothesis. That's a true HO. That is type 1 error. Then what is type 2 error? We also have an error known as type 2 error. We also have an error known as type 2. And type 2 error has to do with you retaining HO when in reality HO is false, or when in reality H1 is true. Because if H1 is true, then it means HO is false. So it means you retain HO when indeed HO is false. It means that you've committed type 2 error. You've committed type 2 error. Apart from this, you should also know something known as power. Power. So they could ask you, what is power? So power has to do with you making a correct decision. That's power. Sorry. Power has to do with you making a correct decision. That is power. So it means the probability of rejecting HO when HO is false, or rejecting HO when H1 is true. That means you've made a good decision. That is power. So basically, these are some of the key things they can ask you. They can ask you what is type 1 error, type 2 error, and power. And these are the things you need to know. So that will be the end of today's discussion. And if you have any questions or issue, you can comment it at the comment section of the YouTube. I would try and address them as soon as possible. And please don't forget to subscribe and turn on the notification button so that you can receive subsequent videos whenever I upload them. Thank you.